Good morning, dear students. We meet already for the third time on lectures on medical informatics and biostatistics. For those who maybe miss previous lecture, my name is Andriy Semenets. I'm Associated Professor of Medical Informatics Department. Today, we'll try to present for you some basic introduction about topics related mostly coding classification, standardization in of information types, information exchanging, interoperability, and similar things, which is related to data exchange in medical informatics. Topics about biosignal processing, which also listed under general lecture description, must be processed via additional materials because it's more related to electrical engineering. Okay, let's start with current topic, lecture materials on coding classification. During this lecture, I will present, so first of all, additional and very useful information source. It's collection of free articles on biomedical informatics. I strongly recommend to navigate there and to review topics which is published here, which could help you in lots of introduction to a lot of questions regarding bioinformatics, biomedical informatics, medical informatics, and health informatics in general. And today's, I will provide introduction into the three major questions, like introduction to classification, and actually I will start with practical aspects of usage of classification and medical and clinical information systems. Then next point will be its presentation of theoretical background, what is classification itself, and brief overview of mostly used medical classification system at the end. So actually I will touch that third question multiple times during second, but then still summarize with them. Now let's proceed with first question, introduction and practical aspects, practical application of classification methodologies. So our major aim at usage, major different classification system, along with patient record, along with medical documentation. So in traditional patient records, they are available in write format only, mainly as free text, sometimes also as numeric data, laboratory test results, and so on. And it was used for decades, even hundreds of years. So reconstruction of patient history from such handwritten patient record by clinician, other than original author, is hindered by the fact that many medical terms are defined and perhaps even ambiguous. Actually, even by original author, after significant time, it's not easy to reconstruct origin of data and needs some effort. It's my own experience. So medical coding is the process of assigning standardized medical codes like numerical, mnemonical, or combination of it to patient medical chart. So this code information used for, first of all, it's medical content standardization, so bring it to more efficient, comprehensive, and straightforward for understanding representation. And also have multiply additional usage, like, for example, exchange information between different facilities, providing different statistics, for example, insurance companies, government, World Health Organization, and multiply extra purpose, like creating, for example, some billing statements or performance chart, or and more. So main idea, it's replacing writing text with specific standardized medical codes. In this case, I mean not only usage not only application of medical coding with computer assistance, with computer patient record also, but in general, because medical coding system could be also applied and already applied for a long time, for decades, with conventional paper-based patient record too. And here is example how could look like patient record, for example, before minimal standardized, only separated into section and fully generated patient record at left side. Here is do we have these things, and how it could be improved only also in paper format, but when we will use maximization of structures, when we will use maximum available different support of different coding system, like here, for example, or so. And we can, let's say, much more useful and much more easy to understand even paper record. And also another example how we can still have hard to be reading formatted and organized paper records. So here is like daily emergency department, daily chat. So it's still not easy to, despite its well formatted and represented as tabular format and even some supporting kind of barcodes or so, but still handwritten part hard to be read. And it is obvious we are talking about emergency departments, so main efforts forwarded to patient but not to documentation. And okay, in this case, very useful become usage of electronic medical records, which can provide for us ability to accurately fill this data, and even possible automatic recording by using interaction with different medical instruments. So again, we still have aim to replace even well-structured and standardized paper records with final aim with electronic data representation. But it's important to have in mind that assigning coding using standardization, it's important steps, even if we're talking about still usage of paper records. And it's critical usage of coding, usage of standards, it's critical to establish interoperability in healthcare, in this development, which is importance extremely grow with development of with application of information technologies and with development of and usage of medical and clinical hospital information system, electronic medical records and other components. So in this case, in these meanings, in these times, it's interoperability, it's ability of different information technology system and software application to communicate, to exchange data accurately, effectively, and consistently, and use information that had been exchanged. So it's ability to send data packages from one system which describe patient records, and it's ensure that it will be retrieved into another system and properly processed, properly decoded and processed. So as of about levels of data interoperability, of data structuring, multiply classification available, but at least this basic 4 level of data structures like non-electronic, machine transportable, machine organizable, and machine interpretable data. For sure, conventional papers, conventional paper records, paper mails, phone calls, it's all non-electronic data. Then machine transportable data, it's like fax, emails, unindexed documents. At this level, we can also turn non-electronic data in machine transportable data, like when we perform scan of patient records or recording of voice call. Okay, it's become machine transportable, but no more. Still does not have any structures inside, and next level will be in bring kind of structures. And here is we for the first time met these things, HL7 or HEOS level 7 international standards which depict multiple aspects of medical information exchanging. And in this case, we are talking about only HL7 messages or structured messages which could be automatically at least processed, at least on administrative level. So we have indexed, labeled documents, images, and objects. So it's at least could be structure of these documents could be processed and analyzed automatically. And last level, most advanced, machine interpretable data, when we have not only structured content, structured messages, but also we have standardized content. So it means that we have full abilities to exchange, for example, electronic patient record from one system to another as HL7 message, and moreover, it will automatically be fit with appropriate fields under recipient system. So, okay. As of about a little bit more words about what is HEOS level 7 is, as I mentioned, international standard developed organization that established to enable interoperability of healthcare information or ability to tumor system combination information. It was founded in 1987, initially focused on interoperability among information system with large hospitals. And later, its organization began focusing on interoperability among apologize, happens some accidents. So, a right organization began focusing on interoperability among systems in disparate organization, including public health. At this moment, most of modern medical information systems supports these international standards and allow to exchange medical information data packages between such systems. As if we are looking about history, so they are given a timeline which represent major steps, major advances in HL7 development and adoption. And also you can see how changed even names of the standard under different circumstances and which components has been introduced. Actually, it's not a full history of HL7, not finished within 2004. It's continued even up to 9, and we have new components since NC, since clinical document architecture, which is started in 2001. We have newest version of HL7 covered here, fast health record interoperability messages, which is introduced a few years ago. But why I show this chart? Because even now still available lots of system which is already working in hospitals, especially in high development countries, with still use relatively old version of HL7, like 2.4, 2.5, and so on. So despite available third version of HL7, despite available most advanced here, we still very often have in use old version of such communication system. So backward compatibility, it's critically important in such kind of information technology system. And the role of standardization of information grow with, like, even I can't talk limits how it's significantly grown and how it's important. So conventional scenario how HL7 could be used, it's when we want two different facilities, one to exchange some medical records data, send their encode, convert in HL7, transmit to receive it, where data has been decoded, processed, created some responses, which is again formatted under HL7 and reverted back to, send it back to original facility if necessary. Sometimes, not every time it's necessary. So here is we have at least 4 positions where HL7 in encoding decoding process is required. Our data packages under HL7 represent some version of clinical document architecture. When we talk about its electronic equivalent of paper document, and consist of this specific useful section where, for example, header explain, header provide a description of package, like represent information about subject, author, when, where, created, and so on. And body contain medical records itself, which consists of human readable section, but as well computer consumable data or some entities. So means CDA could be partially read and understand by humans, but actually it's mainly dedicated to being automatically processed and contain almost unreadable major part, which is actually contain sufficient and most important data for regarding patient condition. So here is example how we can, maybe very small, how could look like that part, almost unreadable part of CDA document. It's consists of multiply abbreviates and values, so it's not be completely unreadable by the humans, but required significant efforts to understand all these components of this reading. And for sure, a major approach, it's usage of specific software which allow easy create this document, and same way relatively easy explore it and understand meanings of components. For example, we have, here is just to input code of service which is offered for this patient. We have this dialog box which allow for us search by description or by type and pick necessary value. And for sure, physician will deal with second column which represent human readable statement, and data package will keep only first left column, which is code representation of this service. And even available lots of special software solutions which allow to directly deal with HL7 messages of different version. And when we can encode the code and create some flexible human readable representation, like we have tree-like structured messages at left side, and we have full packages at right side. As you can see, as I mentioned, it's not fully readable, but with this hint tool, we can even identify what this specific code means. And as latest components of HL7, it's fast health interoperable resources standard, which is adopted in 2017. combine best features of version 2nd and 3rd of clinical document architecture of from Core HL7. Actually, already up to now fully adopted, and major points that it's to introduce and use JSON JavaScript object as universal container for data exchange. And here is we have like evolution of internal structure of HL7. When we started with minimum readable text document in version like 2000, 2.4, 2.5, 2.7, then moved into XML representation. Even I not provide such 3.0 version of HL7, it's XML based. I even not provide some pictures because it was not even widely applied to bank usage. And latest, which has become very popular, extremely fast, it's here, which use very easy to be read, understand, and manage it JSON format. And here is at left side at top shown support of different version of HL7 by one of the three medical information system, OpenMRS. And here is, as you can see, we have like different version which is represented, which are available, and how it can be supported. Such as this slide has been prepared about 1.5 years ago. Major change which happens that they adopt here, and now they allow import of here packages too. Similar way, another popular in open source medical information system, OpenEMR, now also becomes supports of here too. So if we will like finalize with this part of with this question of lecture, as I mentioned, I have started with practical usage of medical codes, with practical usage, especially in case if we use some kind of medical information system along with in our practice. So classification gives for us ability to reduce amount of data which is stored within patient record. And what is much more important is to standardize terminology and provide strong, reliable representation of content. So it could be content will be interpreted only in single, correct, straightforward direction. Also, it's have lots of additional minor advantages. It's like statistical overview and researching ability to better ability to management and planning. It's actually key reasons that give for us ability to implement electronic medical records. So once we have standardized medical data, we have ability to perform uniform implementation with digital computers. And final steps, it's establishing interoperability between different systems. Within digital age, we have significant risks regarding to usage of not only directly from encoding medical data, but just its consequence of interoperability, its consequence of ability to make request for remote request for hospital information system and receive response. And for example, it's sometimes if patient-based service, which is much more vulnerable than enterprise hospital systems. And given article explains some concerns regarding lost personal medical details, lost some kind of privacy. That's, again, it's not direct consequence of usage of coding. It's consequence of maybe not proper implementation of various information technologies. And at the end of first question, I give this chart. You can also, let's say, give this list. You can also take it with PDF version of presentation, and all these items work as links to different articles on the Mention and Wikipedia handbook. For sure, Wikipedia, it's not ideal source, it's not in all cases reliable source, but it's fine starting point to perform investigation on the specific question. And here is we have its only starting point for investigation on the huge direction which is covered on the questions related to standards, coding nomenclature, and the medical informatics. So here is all these things on the medical informatics. It's the reason also why in this lecture I consider only this part from both topics which involved like coding as well as biosignals. So it's only enough time to cover at least basics regarding standards, coding nomenclature. So now I will move into second question, and we'll try to explain what is classification codes in origin, in nutshell, what is background of this terms, items, why we have they are in this manner, and so on. So very actually, as even personally, it's difficult topic, even personally for me, it's hard to understand, but it's important to be introduced and have background on this. So when we talk about classification, we talk about two different meanings: process of design classification and application of that codes classification for specific or coding or description of an object that are using coding or terms that's designate or concept in the classification. So practical application of coding classification system I already noted in first question, and I will a little bit back into third question. So right now we will consider this one question: how classification coding system could be designed and created. So classification is ordered system of concept within domain with implicit or explicit ordering principles. And classification is based every time on prior knowledge and forms the case to expansion of knowledge. So it means we must have background, we must have some set of knowledge, we must have some fact, rules, and important information. And if it's at such point when we have like huge heap of this information, it's reason that we should stop and start to implement some organization, some structures inside. And so that structures come with classification system, which give us order, and classification could be labeled and titled with specific labels, which is covered actually codes. So purpose of classification, support generation of healthcare statistics or to facilitate research. So example of classification of abnormalities of cardiograms or diagnosis of patient into diseases classes. So it's, for example, very simple case, or classification of different flus, classification of different viruses, including modern COVID, and so on. And complexity of classification could be significantly different. Here is example of very simple classification system when we classify abnormalities of ECG only into groups like common, uncommon, and we have most common diseases which cover like 80% of cases. relatively small number. And in contrast, uncommon, something non-standard, non-usual, we have which happens very rarely, but still important to identify it. So here is we have uncommon class. Again, example of classification into two categories, into two groups only. Practically, we have much more and much more complex approaches for classification. So now major definition. We still use term concepts ordered according to generic relations and the classification system. So generic relation is something like AIDS kind of B, pneumonia kind of lung diseases, COVID also kind of lung diseases, where pneumonia represents narrower concept and lung disease represent broader concepts. And for sure, if we have within total classification, we will every time we will have numbers of narrowed concept, which is covered of much broader B concept. We have every time numbers of A items, which is under general parent B classes. So classification contains concept within certain domain, and domain in this term, which is a very common term used very often for different cases. So domain can be defined as set of elements to which a variable or function limited, or any area of interest that might be modeled to create an information system. So if we are working about some information system or some new standard, we need to create first of all domain from this concept that will be covered by this system, no matter electronic or even non-electronic paper or so. Please don't mix term domain with, for example, internet domain or network domain. It's absolutely different things, absolutely different meanings of this word. So example of domain, it's a reason for encounter, diagnosis, medical procedures, and so on. Anatomical sites, it's actually, we have infinite, we could create almost infinite number of domains, even under healthcare. If we will consider from this way, in this respect, national classification of diseases, ICD-9, 10, 11, its classification of diagnosis, and it's allow one to compare findings collected in different environments. So, for example, class if it's done according to single criteria age, so age used as differential criteria. Same way, gender or specific gender, or maybe nationality, and so on. If we continue with ordering principles in classifying of diseases, if we touch a question regarding ICD-9, 10, 11, we deal with aspects among other like anatomical location, etiology, morphology, dysfunction. And each of these aspects can be used for different ordering. And such ordering throughout this classification scaled axis. So we can talk about single axis, multi-axis classification according to one or multiply different classifying criteria. So in multi-axis classification, it's obvious that several ordering principles will be used simultaneously. And we have, for example, ACPC, International Classification of Primary Care. So in this, for instance, diagnosis classified along two axes, one for organ system of alphabetic character and one for components. And we so designed the system for epidemiological purposes. One of problem of uniform registration in healthcare is lack of common terminology or some inconsistency in terminology. And here is we need to use specific things called thesaurus, which is represent list of terms used for a certain application area domain. So list of example of thesaurus, list of diagnostic terms of list on types of laboratory results, or medical informatics for sure have own thesaurus which cover terminology which is most common to being used under medical informatics, for example, in our classes, even in this lecture, and so on. So when we are speaking about specific applications, specific application area, specific area of activity, scientific area, so they every time covered by thesaurus, by list of terms, which is very common to being used in this terminology. And for practical usage, thesaurus also contain list of synonyms. So how we can, when we could use several words, different forms to denote specific entity, specific object, specific term. Would be fine to eliminate some total degree of freedom limited to some given numbers of term, like if we have 20 synonyms, maybe would be enough to cover this particular topic with only 5 or 6 or 7, and it will be, let's say, a restricted set of preferred terms used with an organization for given purpose, covered, controlled vocabulary. So maybe specific diagnosis or symptom or dysfunction, or also when we spoke about the medical informatics or computer technologies in our university or in our country, we prefer specific term from our possible variants of synonyms. And in nomenclature, codes are assigned to medical concept, and medical concept can be combined according to specific rules to form more complex concept. So with usage of nomenclature, we can create, we are almost ready to create encoded message. We can replace our text statement, like description, like label, not description, but title of diagnosis of symptom with corresponded code. But such as in nomenclature, we are almost free to create combination of it. So we have large number of outcome will be its large number of possible code combinations. And now time to sign difference between classification system and nomenclature. So in the first of it, in classification system, all possible codes are predefined. All, and we have like explicitly presented structures which and relationship between code and specific title. Where second, nomenclature, you are free to combine codes from aspects involved. So in classification system, we can put in row several codes. At least we are not free under this. We need to use specific rules. In nomenclature, we almost every time absolutely free to put in rows multiply codes, and probably we should, let's say, something useful, but not in all case in its problem of nomenclature in general. So retrieval of records of patients whose data fully fulfill contain classification code from large database is relatively easy, because we have like clear key value relationship where code represent key, and when we know this key, by search for this key, we immediately will retrieve single value which will means something. Diagnosis, symptom, patient name, or so. In contrast, retrieving error for patients stored by using nomenclature is much more difficult because high degree of freedom leading to very complex codes. So in this case, we could have like not single key value, but we will need to create like complex structure when we will have instead of one key, we will have multiply key values and all allowed. Okay, it's very complex condition. And again, as example, if we will use multi-level classification of medical procedures, and differential criteria here is represented here between these rectangles. It's only if we talk about medical procedures with aim to provide treatment of external ear. So here is we will have one action, equipment, at least pair of aim, anatomical site, and even criteria membership of each subclass not adopted, not provided here. So we have very complex structure to, if we decide to create a medical coding classification system. And now summarize this previously only titles for necessary components, which is useful, which is required and used when we create new medical standards, new classification, which involve classification system every time. So it's like terminology and thesaurus, which give for us a list of terms as well as they some kind of order synonym for them. Classification give for us member and arrangement, give for us order for that terms classification. Vocabulary define all this, so what means of this specific term. Nomenclature could provide composition rules, how we can, if we will need this, how we will can assemble a complete statement. And coding system give for us like last point, it's like called as designators. So before we will be able to apply coding system, we need to resolve issues with above problems. So create thesaurus, arrange nomenclature, prepare vocabulary, apply some organizational principles, and only after that we will be able to apply labels, because so codes and only final labels could be seen as final labels on top of all this. Okay, regarding to example, 1933, New York Academy of Medicine started working on the base of medical terms and standard classification nomenclature of diseases. And later, work continues under Second World War, and finally in 1965, systematic nomenclature of pathologies was published, and now it's SNOP format is basis development of systematic nomenclature of human and veterinary medicine, or SNOMED, which example of nomenclature. And difference between mentioned two system nomenclature SNOMED and National Classification of Diseases. So they cover similar things, but under classification, not available vocabulary and nomenclature. So we doesn't have definition and we doesn't have composition rule for create such for usage of some complex statement. So in this reason, ICD-10 explore information available under SNOMED in case if we need to understand what is this term doesn't mean, terminology given, so thesaurus given. But if we want to understand meanings of term, we need to explore nomenclature and vocabularies. Okay, now move into codes, because it's for us more, for me especially, it's more interesting things like codes. Terminology of coding means that three basic elements used in the colored semantic triangle: object, concept, and term. Object, it's colored reference, particular things in reality. It could be concrete, physical, something technical, biological object, or it could be even abstract, like mind, love, rule, or so. But in this case, it's object. Concept is unit, it's Trolley format by using common properties and set of objects like organs, and term, it's designation by linguistic expression of concept or an object in specific language, or it could be depicted with the following imagination of what is like cell phone or mobile phone or smartphone modern version. So we have like object, abstract object, we have general concept which represent what it should be, and we have term which used to depict it, and it's generally used in different country. We could have different term, sometimes cellular phone, sometimes telephone calling, and so on. But okay, in modern time we mostly use term, even not mobile, but smartphone, smart, and so on. So things, idea of object not changed, but concept not changed. Object changed by changing of models. Designators also changed. So according to this process of assigning of individual object or class to a class or to a set of classes in case of multi-axial classification. Most classification classes are designated by codes. And coding, in fact, is interpretation of aspects of an object. So a simple classification that's used in number of times, but maybe even not assume that it's classification in coding usage. It's like replacing gender statement with their codes, M for male and F for female. Or sometimes use it proper icons, pictures, and so on. So all that things, it's practical usage of coding, and we could have, and even different codes, different type of codes could be represented. So simple way we talk about usage. Okay, different type of codes included, like numbers. Numbers could be issued sequentially, means each new class will be given next and used number. Advantage that's we can very easy add new classes. Another approach, random assignment. So this case very easy to hide some personal specific information. But in this case, will be very difficult to deal with addition new classes or perform some sortings or so on. And series of numbers can be reserved for sets of classes and being issued only under special specific condition. Another approach, mnemonic codes form for one of the more characters in the related class rubrics. And advantage, it's to help users to memorize code. Disadvantage, it's classification with many classes. This may lead to very long codes or codes with resemblance class rubrics or so on, and very useful for limited list of class. So nice example is that's gender encoding, M and F, maybe modern times, and like no provided or third, or okay, at least two basic, it's enough. Also useful example, like when we have departments like medical informatics, MI, and so on. And so very useful approach to provide this. Next approach, it's hierarchical, which are formed by extending an existing code with one or more additional characters for each additional level of detail. And the characters, that means it could be both like other numbers or mnemonic codes or so. So hierarchical code truly bears information on the level of details of related class, and one of the hierarchical relation with its parent class. So this way is coding bears resemblance to structure of hierarchical databases. And actually, it's very closely to things called relational database, which are hierarchical in fact, and even post-relational object database. object-oriented database. And this implies that patient data can be relied by using hierarchical codes at a certain level, even when significant extension of modification are made at lower levels. So example of its relatively old ICD-9. And here is how ICD-9 look like. We have basic codes at 3-digit, which represent diseases, and we can extend it by 1 or 2 additional numerical value to represent some specific case of diseases. Okay, one more type of code, juxtaposition. Composite code consisted of segments. Each segments provide characteristics of associated class for each additional level of details. In this example, we have like building floor location for entitled room. Actually, current group names in our university, it's also adopted by using juxtaposition code when we have mnemonic title which refer to faculty, and speciality which is followed by group number. It's also, again, it's also usage like I am dash 232. It's also representation of juxtaposition codes. So again, application, practical application, if you talk about medical coding, it will be ICPC, National Classification Primary Care, which I already mentioned. It's a diagnostic code. It's formed by using code consisting of the letter of alphabet, mnemonic code followed by 2-digit number. And we have like examples that's starting with D, we have related to tractus digitalus, and code starting with N, describe disorders in nervous system in the CPC. And it's will be look like here. We have to access CPC, we have a list of mnemonic code represent first accents and describe organ system, and the numerical consequence represent component on the axis. What do we have actually as symptoms, diagnosis, treatments, test, what actually want to be encoded. So if we go back to process of encoding medical procedures, they can be classified within principles like action, equipment, aim, and anatomical sites. Combination, for example, consider 100 anatomical sites, 20 different action, 10 different instruments, 5 different purpose, results in classification system with the potential of 100,000 classes and codes. So huge number and hard to be if you want to use only unique value. So way to cope with its use of combination code. So 6-digit combination code consisting 4 segments with segments dedicated to action, 2 digits, equipment, 2 digits, aim, 1 digit, sites, 1 digit, respectively. Its coding clerk has to distinguish only 135 codes. With in total, we have, yes, required 100,000 combination can be generated and achieved. And here is example of combination code. So, and here is below we have description which provide for us understanding of each segment. Actually, in this case, if we back to, for example, juxtaposition code and consider our university group labeling principles, so we have not clear juxtaposition code, we have juxtaposition along with combination, because text label, text part of group label, like I am, referred to 2 segments. First character responsible for faculty, second character responsible for speciality, national student faculty and medical speciality. And then we have followed after dash, we have 3 numbers which typically represent group number, but also that's combination code which have 2 segments, first number refer to course, and then pair of numbers. Decades numbers represent group number. So even it's sometimes not clear to provide distinguish between juxtaposition as well as combination code. And here is how we can understand and properly decoding data from even your group number. So here is we have like obvious things we maybe process even not without some attempts to think, efforts to think around, but it's not simple as could be imagined. Okay, next type of codes, value additional codes, generate only power of 2 and use it as a representation of data items or classes. Several characteristics can be coded, but only one number instead of segment of search characteristics used for code. And we have like, for example, here given a case for bad habits and consequence like increased or not cholesterol. And we have three possible value, six, depending to 1 to 4 and 0 for specific, if it doesn't have this option, if it's no smoker, no overweight, no increased cholesterol. So under decimal number from 1 to 7, we can cover all these cases just by a single decimal number. But for sure, it will be not obvious how to interpret this, how to clearly interpret this data. And for sure, such kind of codes is not for human usage, but value additional codes, it's background which allow for us to create these barcodes and QR codes. So behind the scene, we have value additional codes, but for sure required some technical equipment to read and interpret such codes. Okay, and then about science. So taxonomy, theoretical study of classification included its basic principles, procedures, and rules, and it's concerned with classification in general. So that's things I'm talking about. It's like brief introduction into taxonomy. And term classification used for the end products of designing process. And here is we have proposed cognitive taxonomy of medical errors, for example. Here is in the phone slide view for us, like slips, mistakes, and then we classify drill down below. Nosology, which is usually defined as science of classification of diseases. You will, that term should be known for you, and actually you will deal with it multiply time in your studying. So here is, I will just point that we need to separate nosology from nosologry, which is science of description of diseases. Nosology, it's classification only, and here is difference between description and definition and description. Disease definition give only essential characteristic of disease. Description would accidental characteristics. So what is this and why it's happened, for example. And here is clear, for me personally, it's very often to it's actually important to use proper term in proper condition with proper meanings. So I'm sometimes become very hard with usage of term and asking students about proper usage of term. And such as we now move closely to the in direction of end of lecture, now again overview of most common medical classification system. Like half of it I am already mentioned about that classification system, and just summarize. Practically you will meet and you will deal with these things mostly on clinical subjects. But right now, just brief overview, and I provide that introduction about how classification system brain development, because that question covered under information science, Okay, ICD, ICPCs, NOMAD, DRG, MESH, and ATC. So first of all, again, why it's important. So here is only workflow, flow chart for organization been working. It's not in Ukraine. It's in USA. So how usage of medical coding is important, which kind of medical codes is important, and how coding and billing flow chart organizing. So if you want to, if you are responsible to create medical documentation, maintain medical documentation, and further that source will be used to create billing, insurance statement, and so on. So here is just sign how complex this process could be and how it is actually already. So sometimes it's happy to doesn't have this advanced information technology system. Okay, now back into Go. National Classification of Diseases, archetypal coding system for patient record abstraction. And first edition published like about 120 years ago, typically revised under 10 years interval, now much less. Recent version already ICD-11, but it's not fully adopted, and still 3 editions in use, ICD-9, ICD-10, ICD-11. Mostly ICD-10, like lots of facilities already adopt ICD-11, but still, despite 30 years, we have old ICD-10 in use, and even for about 50 years old ICD-9 still in use. So ICD consists of code classification of 3-digit code, which are minimum required for reporting mortality statistics to World Health Organization. 4-digit provide additional details, and numbers of 0 to 7 used for further details. 8 and 9 are reserved. ICD-9 and 10 and 11 contain set of expansion for other families or medical terms. And all 3 from ICD-9 to 11, they are grouped into chapters, and we have corresponded chapters for ICD-9 and 10. ICD-11 almost descend from ICD-10 and use the same. Most codes are the same, just extended. In United States also adopted ICD-9 clinical modification, which contain like 3rd volume, which contain extra layer, and that's the reason why ICD-9 still very often used in United States, which need also include for medical procedures, because it contains a lot of information about billing. And here is, okay, this example I have already displayed how ICD-9 codes can be formed. And for example, 3rd level ICD-9 CM coding helper software, which could help for select proper procedure. And we can get details and reuse it on our medical history. ICPC. World Organization, National Colleges, Academic Association of General Participation, Family Participation, not at ICD-9, and they came up with own classification, nice classification of primary care, or ICPC. It's 2-axis system, first primarily oriented toward body system tracks and it's coded by letter, and second components coded by 2-digit. So component axis contain 7 code group. So as example, diagnosis pneumonia coded R81 and R respiratory tract 81 diagnostic component. ICPC used to encode encounters structured according to SOA principles like subject, objective information, assessment, and plan. And again, a chart which I already shown for you, which display codes for organ system axis as well as component codes axis. SNOMED. So first of all, I signed that now we are talking about nomenclature, not coding system. So SNOMED was published in 1965, revised in 1979. It's also a multi-axial system. Modern SNOMED International version has 11 axes or modules, and each of these axes form complete hierarchical classification system. So under nomenclature, we have not one classification, we have like family of concurrent classification system. So here is its power and weakness of nomenclature in this way. Like, so diagnosis in SNOMED consists of topographic codes, morphology, urine organism code, functional codes, and well, diagnosis of a combination of these 4 codes exists. The decay diagnosis code is defined. So when we talk about pneumococcal pneumonia, it's equivalent to the combination of like TML, also different codes, which is absolutely defined exactly the same case, but we follow another axis, in other directions. So here is when we start by topology, by morphology, or along living organism axis. Like we have at least 4 ways to achieve the same codes, practically much more, because we have 11 axis classification. Not all codes could be achieved under all this 11 level, but every time we have more than 1, more than 2, more than 3 approach to achieve that specific classified element. And here is list of only axes. Under each one of these axes, we have comprehensive separate classification system with different even principles of classification. And here is example for polyhierarchy and explicit relationship, even if you want to depict infective pneumonia diseases, and how we can identify our possible codes. And for sure here we have extremely raw of information technologies, because search for all this classification manually with different code books, they are definitely available, but it's extremely hard by using paper indexes to achieve our possible indexes. And here is why do we have this like three-wide structure as at the right side. We can only pick codes, but also have ability to, let's say, of all related codes for this case. Okay, DRG, diagnostic related groups, classification based on ICD-9 CM. So again, mostly operate in United States, and other factors not recognized in ICD-9, and now that are in process of adoption of ICD-10 and 11, used mostly for budgeting and creating billings. So actually they added the extra level which refer to cost of treatment or when staying in hospital, severity, complication, and type of treatment. So they contain additional classification options which allow to create bills, to perform budgeting, generate information for insurance companies, and so on. So here is how all that things look like. For sure, it's only general codes, general description. In practical application, we have extra columns which refer to cost of items, totals, and so on. MESH, medical subject headings, classification developed and maintained by National Library of Medicine. So it's actually midline here. And medical headings or MESH, it's midline, it's referred to midline. And used to index world medical literature. And within hierarchy of MESH, a concept may appears as narrowed concept of more than one broader concept. So like pneumonia is listed as respiratory tract infection as well as lung diseases. And here is we can see how MESH it's a fully text classification, full text classification system. So we have like full words which describe specific object, a specific concept in this case, sorry, not object. And here is we have example for respiratory tract diseases and how we can see it under Medline search, under mesh search. Here is selected. We can perform even use as search criteria, and here is will be given a list of our terms. And in response, we will, let's say, you for sure list of scientific article. If you will click this, you will get list of scientific article on this topic. And also how it could be expanded if you want, if you prefer use conventional search. And final things, ATC, anatomic therapeutic chemical codes, so developed for systematic and hierarchical classification of drugs. ACI is acronym for anatomical organ system in the body for which is drug given therapeutic purpose for which drug is used, and chemicals and chemical class for the medicine drug belongs. So developed by Norwegian medical depots in early 1970. Later has been adopted by World Health Organization, especially by drug research groups, which they accept ATC and made it national standard. And at current time, special organ under World Health Organization, Collaborating Center for Drug Statistics Methodology, responsible for maintain ATC codes. So, advantage of ATC, it identifies the drug product, including active substance, route of admission, dosage. It's therapeutically as well as chemically oriented, and that feature most other system work, and hierarchical structure allows for logical grouping, and also it's stable as a national standard. Disadvantage that it does not cover combination of products, sometimes locally compound preparations. Local developers not every time support and properly support ATC codes. For sure, I not consider fraud cases like falsification of medicine or so. Essential idea when you check specific code like this one at the bottom of this chart, you will be unsure what kind of medicine you will take, and you will be unsure about anatomical main group or site that it must work in, which effects, therapeutic effects must be provided, which active substance actually work inside this medicine. In practice, okay, mostly it's fine. So if you want to identify medicine, if it's sometimes you have generic which is sold under different marketing names, okay, we need only ATC code to ensure that it's really this medicine. Probably should be. Okay, that's actually all what I want to present during this lecture. So we have many overlapping classification, not only for coding of diagnoses, but also for classification method events. And most diagnostic code systems try to be compatible with the CD family, which is actually, in fact, for 100 years national standards. But again, it's not a static, and we have significant change between a different edition of national classification of diseases, and I show this by example of ICD-9-10 difference. And nomenclatures such as SNOMED have much more excessive power than small rigid system like ICD-9-CM, but they also bring much more complexity and difficult to be processed, especially without help of computer system. Wide acceptance of coding system is essentially for development of decision support system, and even for conventional medical information system. And international institutions such as World Health Organization with its organized collaborative centers play an important role in standardization process. So finally, if you want to adopt, if you want to develop new information system, we must have some kind of backgrounds. And one key of these backgrounds, it's availability of standards and uniform interpretation of that. And here is what finally I want to talk about this topic. Thank you for your attention and goodbye.